So in my last video I talked about how you could slightly change the speed of one of these cheap cassette players by changing the voltage that you send to the chip that controls the motor. This is the motor, and it does that using pulse width modulation. So as the voltage across a variable resistor changes the voltage that goes into one of these pins, that's registered, and the chip then puts out a varying pulse voltage to the motor, and the higher frequency the pulse, the faster the motor will go, and the lower frequency the pulse, the slower the motor will go. What that means is the range of speed control that you can give the motor in this method is quite small, because essentially all you're doing is breaking out the trim pot, and the trim pot is something that's built into the cassette player to enable you to make small adjustments to the speed in order just to bring it up to spec so that everything sounds the correct speed, the correct pitch. I was thinking that we might be able to get more speed control if we bypassed this chip. So we didn't use the pulse width modulation at all, we just applied a voltage to the motor. So I just went a bit more quick and dirty and just used some batteries and a variable resistor. The idea being that I can change the voltage drop across the variable resistor, which will give me more or less voltage available to go to the motor. Okay, so if I apply a voltage directly to the terminals of the motor, which are helpfully labelled M on the circuit board, you can hear that clicking because there's something caught in the cogs, but what that shows is the motor is actually turning. You can just about see it in the back of the picture here. And if I change the resistance on the variable resistor, the speed does indeed change. So that's now at full speed, in fact probably faster than it should be on the full voltage coming out of the battery pack. However, I've come into a similar problem as I did with the pulse width modulation method, in that the motor seems to have a limited range of speeds that it'll run at. So I don't think by direct driving this motor I'm going to get what I want, which is to be able to play my tapes really slowly. So I'm looking at a couple of alternative methods. One would be mechanical, so looking at changing the gearing or the routing of the belt to slow it down. But the other would be just to do away with this motor altogether and, maybe get into something like Arduino to have a motor that I can control more directly. The other thing that I want to be able to do, even if I bypass most of the gubbins in here, would be to be able to use the play button. And I think that's relatively easy, because if we look down here, there's a tiny leaf switch, and that's connected to the play button. So when I press play, this switch engages, and the switch terminals are on the back here, so they're actually really easy to get to. So what I've got here is a direct mechanical linkage to the play button, so I can use that switch to mean that whatever method I use to control the tape player, I can still use the play button to power it. So I've had a bit of a rummage around in my Arduino parts, and I do have a bunch of motors that I could potentially use to drive the tape player, but the problem is it actually gets quite complicated, because what we need to do in order to drive a normal motor is to run it off a separate power supply that's like a breakout for the Arduino that will power it. There's a couple of reasons for this. One is we're still in the realms of pulse width modulation, and that means we need a controller that can handle that. The other is when the motors stop rotating, you get a flyback effect, which is as the magnetic field collapses, it pushes current in the wrong direction, and that can damage the Arduino. So for a simpler option, I was looking at using a servo, and I think this has promise. I can run my servo without any breakout boards off a very small Arduino, and that should be fine. But I've hit another hitch, which is that standard servos only rotate with an angle of 180 degrees. They don't do the full 360. So I think what I'm going to do is get myself a 360 rotating servo, run it off this board, chuck these in the tape player, and then I should finally be able to slowly run my tape player. I hope. I don't know, I've not really figured out how I'm going to power the Arduino yet, but anyway, I guess this means there's going to be a part 3. Play. Stop. Play. Stop. So this is a servo running off an Arduino, but the play and stop is coming via the leaf switch on the tape player, which when I press play it grounds one of the pins on here, and that grounding of the pin is registered as a low in the code, and when that pin goes low, shit happens. That's really cool. Here's my box of broken electronics, and it's embarrassingly full. There we go. So this is the original circuit board that I've taken out, and essentially everything's controlled by this chip. So we've got power output and we've got some capacitors that control the smoothing of the power, the regulation of the power. But the speed of the motor and all of the audio functions are controlled by this chip. And then we've got another chip over here which I think does the control of sending audio into a USB port. So I don't really want any of this. This is from my earlier mod where I took out a variable resistor that lived here and replaced it with a pot I could get to, so I could do some limited speed control. Since the preamplifier stages on the original tape player were built into the same chip that I've now discarded, I needed a preamp. So this is what this is going to do, is take audio, and the audio comes down this grey wire, so this is just left and right that's coming directly off the heads. I might be able to show you that. Yeah, so this is our playhead. I have no idea if the camera's recording. And this playhead is wired in to this grey wire, so the audio left and right and neutral comes down this wire. The problem with that is it's very low amplitude, so that needs to go through a preamplifier stage before it gets outputted, and that's what this box is doing. And this is overkill for what I'm doing, but hey, it'll look cool. And this can run off mains or battery, but this is going to be running off the same 12-volt power supply that the Arduino is going to be running off. So it basically just needs a bit of hot glue and a bit of fixing to finish off. This wire in the preamp's come undone, so I need to fix that. This is going to get glued onto the other side of the tape player, and I think I'll probably glue the Arduino into the battery slot once I'm 100% certain I'm happy with the code. But yeah, I'm really happy with it. It's droning, which is what I want. Getting a lot of electrical noise off the servo. Possibly something I'll need to notch out with some EQ, but broadly it's doing what it's supposed to. I don't fully understand how the heads work on the tape player, because you've got 4 tracks on a tape, 2 in one direction, 2 in the other direction, and at the moment I've just got 2 cables coming off, sort of left and right, coming off the heads, and only one of those is producing usable output. So yeah, I think I need to do a bit more investigation about how this actually works, but broadly speaking, I'd say it's kind of successful and extremely messy, which I kind of dig, so that's okay. Well, I've successfully, sort of, made a drone cassette player, and honestly, I can't wait to pick up some Rick Astley in a charity shop and just play it for hours on end in a really sort of doomy and miserable way.